All right, welcome back. Now that we've done one example really thoroughly, the next couple, we're going to go much quicker. All right, so for number 2, y equals negative x squared plus 4x. Step 1, we're going to write down our a, b, and c. All right, so we have negative 1 for our a value. Remember, there's an invisible 1 right in front of the x squared. B is positive 4, and c, as you notice here, is missing. We don't have a constant. So it's the same thing as saying plus 0. Now that we have a, b, and c listed down, we're going to identify if the parabola opens up or down. Remember, you want to look at the a value to determine that. Our a value is negative, so that means that our parabola is going to open down. So it's going to look like this. Oop, let me change the color. It's going to look like this. Okay, because it's a negative 1 a value. A is negative 1. Okay, let's go on to step 2. We're going to find the axis of symmetry now, the line that's going to go down this parabola and cross through its vertex. To find it, we're going to apply our formula, negative b over 2a. Negative, I'm going to write that down first, then I'm going to look at b. b is a positive 4 over 2 times a, which is negative 1. Let's simplify. Negative 4 over 2 times negative 1, which is negative 2. The two negatives are going to become a positive. 4 divided by 2 is 2. So our equation is x equals 2 for this vertical line. All right, so we have an imaginary vertical line, that's the axis of symmetry, that's going to pass through 2 on the x-axis. Also, that 2 is now going to be the x-coordinate for our vertex. So this point right here, it's going to have 2 as its x-coordinate. Let's figure out the y-coordinate. To figure that out, we have to plug in 2 into our quadratic equation. Before I use function notation, now I'm going to write it as a regular equation with a y value because we're solving for the y value. So y equals negative, parentheses, I'm going to put 2 for my x squared plus 4 times 2. All right, let's simplify this. So y equals negative 2 squared is 4 plus 4 times 2, which is 8. So y equals negative 4 plus 8, which is 4. So our y value is 4. Our vertex is located at 2, 4. And now we're going to circle. Is this vertex a maximum or a minimum? Well, it's a maximum because if your parabola is upside down like this point where the vertex is, where it's 2, 4, that's the highest point on your parabola. It doesn't go above that. It's the maximum point, the maximum y value. All right, let's go on to step 4. Find the y-intercept. Now, if you recall, the y-intercept, when you're looking at a quadratic, is your c value. It's your constant. Since your c value here we saw was 0, they had no constant, that means your y-intercept is 0, 0. This parabola is going to cross the y-axis at the origin, okay? All right, so next, find the x-intercepts. Okay, so if we're looking for the x-intercepts, we had two options. We're either going to factor or we're going to use the quadratic formula. I'm going to write down the equation again. Y equals negative x squared plus 4x. Okay, let me check if that's the correct equation. Yep, negative x squared plus 4x. All right, so what I'm going to do is I'm going to factor. I think that's going to be a lot easier in this particular example. So when I factor this, I'm going to have y equals, I notice that negative x squared and 4x, they do have a greatest common factor that I can take out before I even get started. They both have an x, so I can definitely take out an x. but also I don't really like having a negative coefficient to my x squared. So I'm going to take out a negative 1. So I'm going to take out a negative x. I'm going to factor out a negative x, which leaves me with x, right? Because negative x times x, just so you know, negative x times x is going to give me negative x squared. So that makes sense for that first term. And then if I factor out a negative x from 4x, I'm going to get a negative 4, and I'm not going to have any x left over, which again should make sense because if I do negative x times negative 4, the two negatives are going to become a positive, and then I'm going to have the x come along. All right, so it's negative x, parentheses, x minus 4. I'm going to have to now substitute out the y and put a 0. In order to figure out my x-intercepts, my roots, I need to make the equation equal to 0. So it's going to be 0 equals negative x, parentheses, x minus 4. Each one of these I'm going to set equal to 0. I like to call it t'ing it out. I'm going to t it out, all right, because I create a little t here. So for the left one, negative x is going to equal 0, and then x minus 4 is going to equal 0. For the one on the left, negative x equals 0. If I divide both sides by that negative 1 in order to just isolate the x value, this will cancel, and I'll be left with x equals 0 divided by anything, a negative 1, a negative 2, it doesn't matter. 0 divided by anything gives you 0. And then on the right-hand side, x minus 4 equals 0. I'm going to add 4 to both sides. And I'm going to be left with x equals 4. So those are my two roots. I have a root at 0 and then a root at 4. So I can write down that my solutions are 0, 4. Notice I'm doing curly brackets because I'm listing out the different solutions. I'm not writing a coordinate. If I were to write the coordinate of the two x-intercepts, it would be 0, 0, and then it would be 4, 0. Those are my two x-intercepts. Okay, it's time now to graph. So the first thing that I'm going to graph is I'm going to graph my axis of symmetry. All right, so my axis of symmetry is going to be at, let me check back. My axis of symmetry was at 2. All right, so let's go ahead and write this down. I have x equals 2. All right, go to 2. Notice my graph is a little bit different. Each one of those lines, each one of the grid lines is 0.5. So that's where my 2 is. All right, I'm going to draw my axis of symmetry. Remember, this is an invisible line. It's not really part of your parabola. It's what helps us graph your parabola. I know my vertex is along there somewhere. Going back to my notes, my vertex is at 2, 4. Okay, so the next thing I'm going to graph is the 2, 4. 2, 4. All right, so my vertex is right here. All right, I'm going to change the color so it really sticks out. All right, so 2, 4, that's my first point that I know that is going to be on my parabola. Now, the next one that I'm going to graph is I'm going to graph the y-intercept, which we saw is 0, okay, because that's the constant. It's 0. All right, so that's actually also one of our roots, which makes sense. What is our other root? Our other root was at 4, 0. Now notice, usually when we graph our y-intercept, we're going to go ahead and make sure that we have a reflected point on the other side of the axis of symmetry. Now if I were to reflect it, I would go 1, 2, and then again 1, 2, and notice the other root is already my reflected y-intercept. So all of these things are working together. All right, so I'm going to go ahead, I'm going to delete these two little pieces. All right. So now that I've plotted my axis of symmetry, I have my vertex and I have my roots. I know this parabola is upside down and that looks like what I have here. I'm ready to just sketch it now. All right, those key pieces of information. Now let me go ahead and sketch. So I'm going to create a curve as best as I can. Try not to make it pointy. Okay, add my end behavior arrows. And there we go. That is our sketched parabola. Now, I'm going to go ahead and ask you the same questions I did before. What's our domain? What's our range? Now, again, since our end behavior here, we've included the arrows. The domain means that it's going to extend to the left and extend to the right because it's going to go on for forever. That's why we include those arrows on the parabola. So our domain is all real numbers. Okay, it's going to go infinitely to the left and to the right. And remember, the x values, that's what we're asking for when we're asking for the domain. What possible x values will you have that will be part of this graph? Now, the next question is, what's the range? Well, the range is going to be restricted because there's always a maximum or a minimum point. In this case, we have a maximum point. The vertex is your maximum, meaning right here, that's your limit. You're not going above 4 on the y-axis. You're not going anywhere above that point, which means 4 is the very highest y value that you can have. Now you have all of these other y values going down, because remember, your parabola will continue going down, 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 down. So you're going to have negative infinity, negative 100 million. That could be possible. So how do we write that down for our range? We're going to say, okay, well, your y value is less than or equal to 4, because our point is at 4. So any value less than 4 or equal to 4 is part of our parabola graph. So for example, if I ask you about negative 0.5, is negative 0.5 a y value that exists on this function? Well, you would say, yeah, it is, because right here, where negative 0.5 is, I have a point on my graph. I also have one here. All right, so negative 0.5 is part of my range. All right, let's go on to the next question. Number 3, y equals 2x squared plus 12x plus 20. Write down A, B, and C. Positive 2, positive 12, positive 20. Snazzing it up with a different color pen. All right, the question is, does this parabola open up or down? Remember, to figure that out, all you care about is A. A is positive, so that means it opens up. It's a regular U-value parabola. It's going to look like, ooh, don't want that color. It's going to look like this, right? Because you have a positive A value. A is positive 2. All right, now that we know that our parabola opens up, we're going to figure out what is this axis of symmetry so that we can get closer. We can get closer to figuring out where our vertex is. All right, our axis of symmetry. We're going to write down our equation, negative b over 2a. Our b value is 12, so negative parentheses 12 over 2 parentheses, and our a value is 2. Simplify, negative 12 over 4 gives us negative, because we have a negative and a positive, so a negative 3. So x equals negative 3 is the vertical line equation. All right, so this axis of symmetry has the equation x equals negative 3, which means our vertex here has a negative 3x value. Now to figure out the y value of our vertex, we're going to plug in this negative 3 and figure out our output y value. Okay, so I'm going to write function notation again because I like going between the two so that you know either way that you see your quadratic, you do the same thing. So we're going to do f of negative 3 to see what our output is going to be. So we're going to have 2 parentheses, negative 3 squared plus 12 parentheses, negative 3 plus 20. Okay, start evaluating. 2. Now these parentheses, negative 3 squared, that means negative 3 times negative 3. Negative 3 times negative 3 is a positive 9. Once you square something, the negative goes away. Plus 12 times negative 3. Well, one's positive, one's negative, so we're going to have a negative here. 12 times 3 is 36. And then lastly, we have positive 20. So now let's evaluate a little bit further. 2 times 9 is 18. Minus 36 plus 20. 18 minus 36 is negative 18. And then we're going to add 20, which gives us a positive 2. So the vertex is at negative 3, positive 2. We know exactly where that vertex is on our graph. Now, question is, you have to think about this. Is this vertex a maximum or a minimum? Well, since your parabola opens up, because there's a positive a value, since your parabola opens up, that means at this point where the vertex is, that looks like the lowest point on your graph. It's a minimum. All right, let's go on to step 4. Find the y-intercept. Our y-intercept is always our c. Our c here is 20. So that means our y-intercept is going to be at 0, 20. And then we're going to go on to our x-intercepts. So to find our x-intercepts, remember, quadratic formula or factor. I'm going to factor just so that we can continue to review what we did last week. And I'm going to write down this equation, 2x squared plus 12x plus 20. Okay, so I'm going to zoom in. Okay, and now we have y equals 2x squared plus 12x plus 20. All right, first step, I like to always try and factor something out if I can. I notice that all of these coefficients, 2, 12, and 20, they're all even. So I definitely know I can factor out a 2. All right, so I'm going to go ahead, I'm going to factor out 2. So it's going to be y equals 2 x squared. 12 divided by 2 is 6, so we have 6x. 20 divided by 2 is 10. All right, so we factor that out. Now, looking at x squared plus 6x plus 10, I'm going to try and figure out what are the factors of 10 that will add up to positive 6. All right, so factors of 10, I'm going to write it on the side here. I have 5 and 2, and I have 10 and 1. I'm looking to get a positive 6, so I don't have to make any of these negative. If I wanted to multiply it to a positive 10, I could either make both factors positive or both factors could be negative and still give me a positive 10. But since I want a positive 6 for them to add up to, I'm going to stick all positive. So here we go. Here we have 5 and 2, which gives us 7. Then we have 10 and 1, which gives us 11. Now that's really weird because those are all of the factors I can think of, and none of these work. So now I'm thinking to myself, I don't think I could factor this. I don't think it works. Now remember what we went over. We went over something called the discriminant, which will tell us whether or not this particular quadratic will have any roots, any x-intercepts, or any solutions. Let's go ahead and let's look at our discriminant to see if we can figure out whether or not the fact that we can't factor this makes sense. All right, so our discriminant is b squared minus 4ac. It's what's under the square root in your quadratic. So if this ends up being positive value, okay, then there should be 2 roots. So we should be getting 2 solutions. If this b squared minus 4ac ends up being 0, that means it's going to have 1 root. Okay, it's going to touch the x-axis at 1 point. And then if we have a negative here for b squared minus 4ac, we're going to have 0 roots, meaning that your parabola is either going to be above or below the x-axis, but never intersect it. So let's go ahead and we're trying to figure out what this discriminant is. So our b value is 12, so I'm going to plug that in, 12 squared minus 4 times 2 for our A value times 20. Okay, so now 12 squared is 144 minus 4 times 2, I'm going to start there. 4 times 2 is 8 times 20. Right? I multiplied these two together first. Going one step further, 144 minus 8 times 20 is going to give me 400. And now 144 minus 400, well, I'm definitely getting negative here. This is definitely going to be a negative. Oh, quick correction. It's not 400, it's 160. But still, 144 minus 160 is definitely going to give you a negative. It's going to give you a negative 16. So if we have a negative discriminant, that means we have 0 roots. So either your equation, change this, either your graph, sorry, not your equation, is going to be completely above the x-axis or completely below the x-axis, and it won't intersect the x-axis. Okay? All right, so let's go ahead and let's try to graph this. We do have a couple of pieces of information. This graph is not the best, so we're just going to sketch, okay? The values on this graph are not the best. So we're going to take a look at what we can graph. So I'm going to always start with my axis of symmetry, which is at -3. So start there. All right, x equals -3 is plotted. Now our vertex is located at -3, 2. And we said that this is an up-facing parabola, all right? So this vertex is our minimum. Now, my next question is, well, where is the y-intercept? Where is this going to cross? It's going to cross at 20, which is far above our graph. So we're just going to have to imagine where it is, all right? This is probably still too low, but we're limited with our space. So let's say that is our y-intercept up there, which means our other y-intercept, if we reflect it over the axis of symmetry, will be somewhere around there. And maybe a little bit closer, actually. Let me fix that. A little bit closer. So maybe it's like right here. All right, right where the -6 is. And now we're going to connect all of these points. Okay? All right, so this is just a rough sketch, but notice it has no roots. Now, question is domain and range. Our domain, which is our x values, still all real numbers. Okay? Unless it's a real world situation, it's going to be all real numbers. And then the range, our y values, okay? It looks like our lowest y value is here at 2. And then the graph continues going upwards, so we can go anything higher than 2. So to write that, we're going to do y is greater than or equal to a positive 2. All right, let's go on to our last problem. Okay, last one, number 4. Do not be alerted just because you see a fraction. We're going to work through it. All right, so y equals 1/2 x squared plus 4x plus 10. Let's write down our a, b, and c. A is a positive 1/2. B is 4. C is 10. Circle if the parabola opens up or down. Since A is positive, it's going to open up. It's going to be a U shape, upward facing U shape. Okay? All right. Now, find the axis of symmetry. All right, so we're going to look at this invisible axis of symmetry, and we're going to solve for it. So we're going to do -b over 2a. Negative, plug in 4 for the b value, all over 2 times your a value, which is 1/2. -4 for our numerator. 2 times 1/2 is 1. So that means that -4 divided by 1 is -4. So the equation for your vertical axis of symmetry is negative 4. Okay, x equals negative 4. And that means your vertex has an x value that's negative 4. To find the y value, we know what to do. We're going to plug that negative 4 into our equation. All right, let's get started. Y equals 1/2 times negative 4 squared plus 4 times negative 4 plus 10. Y equals 1/2, and now let's go ahead and evaluate negative 4 squared. Negative 4 times negative 4 is 16 positive. So we're going to have here 1/2 times 16. And now positive 4 times a negative 4 is a negative 16. And then bring down the plus 10. All right, let's keep going. Y equals 1/2 times 16 is 8 minus 16 plus 10. 8 minus 16 is negative 8 plus 10 gives you a positive 2. So y equals positive 2. So your vertex is at negative 4, positive 2. And now this vertex, it's clearly a minimum because it's right at the bottom of our parabola. It's a minimum point. It's the lowest point in your parabola. And let's move on. Find the y-intercept. Okay, the y-intercept is your constant. So our constant c is equal to 10. So our y-intercept is going to be at 0, 10. All right. Last piece here, we're going to find our x-intercepts. So remember, we can either factor or we can use the quadratic formula. All right. In this one, I'm going to use the quadratic formula just so that we get the practice with it all. All right. So the first thing I'm going to do when using the quadratic formula, I'm going to write down A, B, and C. A is 1/2. B is equal to, I believe it was 4. Let me check. 4, and then C is 10. Okay, so let me go ahead and write down what my quadratic equation is, or rather quadratic formula. So x equals, I kind of like this Pop Goes the Weasel song. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's how I remember it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, if you can remember that, you're never going to forget the quadratic formula. All right, let's go ahead and let's plug in. So x equals negative, our b value is 4, plus or minus the square root, b squared. So 4 squared minus 4, a is 1/2, and then c is 10. Okay. All over 2 times a, which is 1/2. Okay, so let's start simplifying. Negative 4 plus or minus, the square root's really where we have the harder stuff that we need to simplify. Well, 4 squared, right here, 4 squared is going to give you 16. And now minus 4 times a positive 1/2 times a positive 10. We only have one negative along this route, so it's going to end up being a negative for whatever it is that we multiply together. 4 times 1/2 is 2. 2 times 10 is 20. So I'm going to put down 20. All over 2 times 1/2, which is 1. Okay, let's keep going. X equals negative 4 plus or minus square root 16 minus 20. That gives me a negative 4. All over 1, We don't even have to write the all over 1. Now, you should see something that jumps out at you that gives you a problem. Right now, our next step would be to take the square root of -4 and then break out your equation into 2 parts. X equals -4 plus the square root of -4, and then x equals -4 minus the square root of -4. So we kind of break up this plus or minus stuff right there. The issue is you can't take the square root of a negative number, at least not in Algebra 1. We'll cover that in Algebra 2. If you take the square root of a negative number, you get something called an imaginary number. And we're not doing that right now. So if you get a negative number under your square root, that means your discriminant, which is the value under the square root, is negative. If your discriminant is negative, that means there are no real roots. Okay, so recall what we did last problem. Our discriminant, the number underneath the radical, is negative. So there are no solutions, no roots, no x-intercepts. Your parabola is going to be above the x-axis and never cross it. Okay, so look at what we were doing. We were going through the process of using the quadratic formula. Then we got to the part where it's time to take the square root. We realize it's negative, and then we stop. All right, because that tells us it's not going to cross the x-axis. So there are no x-intercepts. All right, let's go ahead and let's graph what we have with the information that we have. All right, so let's start with our axis of symmetry, which is at -4. So I'm going to go ahead and I'm going to draw my axis of symmetry at -4. And now I'm going to plot my vertex. So my vertex is at -4, 2. So here it is. I know it's an upward-facing parabola. Okay, it's going to be an upward-facing parabola because we have a positive a value. Right? So it's going to be something like this. That was a quick sketch just to remind you. All right, so now we're going to plot our y-intercept. Now again, our y-intercept of 10 is far above where this axis allows us to plot. So I'm going to just imagine that 10 is about here. It would have been nice to have a different graph, but we can make do. All right, so 10 is above where we have. So maybe it's around there. So if I were to get the axis of symmetry and reflect this point, okay, the equivalent one on the other side, maybe it's right around there. All right, so now we're going to connect these 3 points. Put on our arrows to show our end behavior, and that's a rough sketch of what this parabola is going to look like. All right, so now I'm going to go ahead and do the last piece, which is to ask you what our domain and our range is. So domain and range. So remember, the domain, most of the time, if it's not a real world problem, it's going to be all real numbers. So I'm just going to write that down. Now our range, we take a look at where our vertex is. Our vertex is at 2. It's not going to go below 2. So we need to write an inequality that says it's 2 or higher, right? Because it does go up. It does go up. So to write that out, we're going to write y, which is our y values, right? Our range are for y values, is greater than or equal to 2. And that's how you would graph quadratic equations that are in standard form using this 5-step process to get the key features. All right, so all of these pieces that you've been doing are going to work together. You're looking at the quadratic formula if you're looking for x-intercepts. You're going to be using the discriminant if your quadratic formula isn't working out for you. You're going to be potentially using factoring if you don't want to use the quadratic formula. And then we have all of these other things that we've been looking at in terms of our vocabulary, the vertex, the axis of symmetry, opening upwards or downwards, maximum, minimum. All of these things are coming together when you start graphing. All right, so we've used graphing using a 5-step process of finding key features. The next time you're going to look at a lesson, you're going to look at how to graph a quadratic using a table of values instead of trying to find all of these key features. But either method you end up going with is going to get you a nice sketch. All right, catch you soon.